In Unit A of Algebra 1, students spend the first half of the unit writing and solving linear equations and writing and solving systems of linear equations. A system of linear equations is a set of two or more equations that are solved together. The equations are typically shown with a brace, showing which two equations are in the same problem together, as we see here. A solution for a system of linear equations is when we have an answer for every variable or letter in both equations. So because both of these equations in each problem here have an x and a y, we need to have an answer for the x and for the y. And we write our answers as a coordinate pair like this, x comma y, because it's in alphabetical order, and that's just the typical notation for mathematics. This solution for a system of equations is actually a solution that will make both equations true. Students solve system of equations in four ways: tables, graphs, substitution, and elimination. Here we are taking a look at Lesson 15, Task 15.3, which is about solving systems of equation using elimination. Take a moment to read the task and also the problems that students are asked to solve. For this video, we are focusing on problem D. When solving systems of equations using elimination, it is helpful to have our equations set up like this, and that's to have the x's stacked on top of each other, the y's stacked on top of each other, and also our number at the end that doesn't have a variable on top of each other like this as well. When I'm solving a system of equations using elimination, what I like to do is I like to look at the numbers on the left side, so the numbers in front of my variables, also known as coefficients, that's what these numbers are called, and I like to see if the numbers are the same. So as I can see in problem C, that the x's are the same, they both have 2x. But for this problem for D, the x's are not the same, it's 2x and 6x. The y's are also not the same, it's 3y and negative 5y. So in order for elimination to work, we would have to add or subtract these two equations together, and one of the variables has to eliminate or be 0. And if I add these equations or subtract these equations right now, none of the variables will go away. So what I actually have to do first is I do need to multiply one of these equations, the top one or the bottom one, by a number so that I will have the same number for the x's or the same number for the y's. So I like to go from left to right. So what I do first is I look at my x's and I ask myself, is there a number I can multiply? 2 times what will give me 6? Or the other way around, 6 times what is 2? Well, I know that 2 times 3 is 6. So I'm actually going to multiply this top equation by 3 to make my x's match. Now, when I do this multiplication, I need to multiply everything in this top equation, in this first equation, by 3. So, because I multiplied the left side of my equation by 3, I also have to multiply the right side of my equation as 3 also, because that will make this equivalent equation, or an equation that has the same answer. So I have 3 times 2x. I know 3 times 2 is 6, so that's 6x. And I have 3 times positive 3, which is 9, so 9y, equals 16 times 3, which is 48. My bottom equation I did not change, so I am just going to bring that down. And what I need to do at this point is I need to either add or subtract these equations together so that one of the variables will eliminate. So if I try adding these equations first, I have 6x plus 6x. I know that 6 plus 6 is 12, so that's 12x. I have 9y minus 5y. 9 minus 5 is 4, equals 48 plus 20, which is 68. Now I can see here that I do have a problem, because for elimination to work, one of the variables has to eliminate or be 0. And by adding these equations together, I actually did not eliminate anything. So addition did not work here, and that's actually because these 6x's have the same sign. So what I'm going to do instead, I'm going to backtrack a little bit, and we're going to try subtraction instead. So let's try subtraction. So I'm going to subtract everything in that second equation. So I'm going to do 6x minus 6x. I know 6 minus 6 is 0, 0x. And I can actually see right here, I did eliminate my x's because I have no x's left. At this point right here with my y's, I have 9y minus negative 5y. And we do have to be a little bit careful with that. So I'm going to write that off to the side here for a second. I have 9y minus negative 5y. I know that I'm doing minus negative. That's actually the same thing as adding. So I have 9y plus 5y, and I can see that I actually have 14 y's. And then on the right side here, I have 48, and again, we are subtracting. 48 minus 20 is 28. So this is my equation after I have eliminated my x. So I can actually cross that off for a second because I have no x's left. At this point, I have 14y equals 28. I need to solve for y, so this 14y is actually 14 times y. So to solve for y, I need to use the inverse operation to get rid of the 14. Or 14 multiplied by y, the opposite of multiplication, or the inverse of multiplication, is division. So I'm going to divide both sides by the number that's being multiplied by my y. So divide both sides by 14. I know 14 divided by 14 is 1. So I have 1y equals 28 divided by 14, which is 2. Now typically in mathematics we don't write 1y, we just write y equals 2, and we have solved for y. Now keep in mind, when we're solving a system of equations, I do need to have a number for my x and for my y, for both variables in this problem. I only have y equals 2. I have not found what x equals. All I know is that I eliminated my x when I got to this point here. So what I need to do is I need to go back to one of my equations in the original. I like this first equation just because these numbers are pretty small. So I'm going to write that equation here. So I have 2x plus 3y equals 16. So what I know is I know that my y equals 2. So instead of writing y, I'm going to write 2. So let me write this equation again. I have 2x. I haven't done anything with the x, so I don't know what it is yet. Plus 3 times y, which I know my y is 2. I'll write that in a second, equals 16. And what I'm actually doing here is I am substituting a 2 in for y because I know y is 2. And now I can finish solving this because I only have one letter here. So I have 2x. I still don't know what that is. Plus 3 times 2 is 6 equals 16. Now what some students will do is they do draw a line when they're solving equations through their equal sign to separate the left side from the right side. And that's just so they remind themselves that what's on the left and what's on the right are two different things and they cannot put these two numbers together. At this point, we need to solve the equation for x. So I need to get rid of the number that's not touching x on the left side here, or on the side with the x. So if I have a plus 6, the inverse operation of plus is minus. So I'm going to subtract 6 on both sides. I'm not doing anything with this 2x still, so I'm just going to bring it down. 6 minus 6 is 0. And I know that 16 minus 6 is 10. Now there's nothing really here with the 0, so you don't actually have to write it. Some students like having it there for a placeholder. And at this point I have 2x equals 10. There is a multiplication between the 2 and the x. So to get the x by itself, I need to use the inverse operation of multiplication, which is division. And I divide both sides by the number that's touching the x. 2 divided by 2 is 1. So I have 1x equals 10 divided by 2 is 5. And again, we don't usually write the 1 in front of the x, so we actually have x equals 5. And at this point, we are done with this problem because I have a number for my x, I have a number for my y. The last thing I need to do is I just need to write my answer as a point, like we had up here, x comma y, alphabetical order. So I write my answer. I know my x is 5, so I'm going to write that first, comma, my y is 2, I'm going to write that second, and this is the solution to this system of equations. Now this task is about solving the system of equations without graphing, but I am going to show you how students can use a graphing technology to solve this equation. So what I'm actually going to do is I'm going to switch to Desmos. It is a free online graphing calculator that students usually use in the classroom. And I'm going to type both those equations into Desmos here in two different lines because they are two different equations. In the second line, my second equation. And this intersection point right here, where both lines touch, is the solution because it makes both equations true. So this solution here is 5, 2, and if I check it against my answer I did with elimination, I do see I also had 5, 2, so that means that is my answer.